Welcome children, Quadrilaterals for class 9. Let's discuss few questions from exercise 8.1. Now our question number 3 is, show that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. Now we are given a quadrilateral ABCD, suppose here, and its diagonal bisect each other at right angles. It means OA is equal to OC and OD equals to OB. So diagonals are bisecting each other and they are bisecting at 90 degree. Means this angle is of 90 degree, this is also 90 degree, this is 90 degree and this is 90 degree. Now we have to prove that it is a rhombus. Now since we know that the diagonals of a quadrilateral are bisecting each other at right angles, so if the diagonals bisect each other, then it is a parallelogram. Second thing, for the rhombus, the properties are it should be a parallelogram, the diagonals should bisect each other at 90 degree, and third thing is that its all sides should be equal. So here we are being given that the diagonals are bisecting each other, and we know that if the diagonals are bisecting each other, then ABCD will be a parallelogram. This is a theorem also. Now let me focus on proving that it is a rhombus by proving that all the four sides are equal. Now this property we have, this result we have obtained by this statement that diagonals bisect each other. Now we have to show that all the four sides of a rhombus are, this quadrilateral, are equal. Now what we have done, first of all we have taken triangle DOA, this triangle, and triangle BOC, this triangle. These two triangles we have taken and we are going to prove them congruent. Now how to prove them congruent? It's very simple to prove here. First of all, OA, you can see OA equal to OC because diagonals are bisecting and it is given. This side OB is equals to OD, this also given, and we know that diagonals are bisecting each other at 90 degrees. This is 90 degrees, this will also be 90 degrees. So you can see side, angle, side, side, angle, side. So these two triangles will become congruent by side, angle, side criteria. And if these two triangles are congruent, we know by CPCT the corresponding parts which are remaining will be equal. So we can say this AD and BC are equal by CPCT. So this result we have obtained here, that AD equal to BC by CPCT. Then again we are taking the triangle AOB, this triangle, we can show it by plus, and triangle COD, this triangle. Again we are going to prove them congruent and same procedure we will follow. OB equal to OD, OA equal to OC, and this angle is of 90 degrees, this angle is of 90 degrees, means vertically opposite angles are equal. So by side, angle, side, these two triangles will be congruent. And if these two are congruent, then this side AB equal to CD. So this we have obtained. Now here we have obtained this result by proving these two triangles congruent. We can simply do this way also. We can write the first statement, since diagonals are bisecting each other, ABCD is a parallelogram, and in a parallelogram the opposite side AD will be equal to BC and second pair AB will be equal to DC. So there we no need to show this proof, we can do directly also. So that depends upon your choice. So we have proved that AD equal to BC, AB equal to DC. Now we will take the two triangles AOB and BOC. AOB, this one, and BOC, this one. We are going to prove them congruent. So simply how can we prove this? OA equal to OC. Why? Because the diagonals are bisecting each other, it is given. Then OB, this OB is common for both the triangles. And third thing, this angle AOB, this is of 90 degree, and this angle BOC, this is also of 90 degree. So you can see side, angle, side, side, angle, side, these two triangles are congruent. And if these two triangles are congruent, then this side AB will be equal to BC. we got this third result, AB equal to BC. Now there are three results we have. First result is AD equal to BC, means these two sides are equal. Second result is these two sides are equal, means opposite sides are equal. And third result is that pair of two adjacent sides AB and BC are equal. So if you will compare the result number 1, 2 and 3, you will obtain that all the four sides are equal. You can understand this way. This thing. See, this side equal to this side is result number 1. This side equal to this, result number 3. So we can say this equal to this equal to this. It means these three are equals. Okay, and result number 2 is saying this side equal to this. So if these three are equal and this equal to this, it means all the four are equal. So we have obtained that here all the four sides are equal. And if all the four sides are equal, then the given quadrilateral will become a rhombus. So this is the proof. Now coming to question number 4. Now question number 4 is, show that diagonals of a square are equal and bisect each other at right angles. Now for a square, the properties of the square are that it is a special type of parallelogram in which all the four sides are equal, diagonals are equal, and diagonals bisect each other at 90 degrees. So out of this we are being given that the diagonals are equal and bisect each other at 90 degrees. So these two things are given. So to prove that this figure is a square, we have to show this, that diagonals of a square are equal, bisect each other at right angles. This we have to show, and we are being given that all the four sides are equal. So using this property, let me show that diagonals are equal and bisect each other at right angles. ये हमें show करना है. So now see, we will take two triangles first of all, ABC, this base triangle, and ADB, this one. These two triangles we can take this one and this one. Now we are going to prove them congruent. So first of all we can see that AB is common for both. Then we can say that this side equals to this side. Why? Because in a square opposite sides are equal. Then because it's a square, then each angle is of 90 degree. So this angle A and this angle B will be of 90 degree. So you can see in these triangles, side, angle, side, side, angle, side. So this way the triangle BAD and ABC, these two triangles are congruent. And if they are congruent, then their remaining parts will be equal. So we can see the side AC, which is the diagonal here, will be equal to side BD. So we obtained this AC equals to BD. It means we have shown by the CPCT result that these two which are making the diagonals of a square are equal to each other. So first part we have proved that diagonals of a square are equal. Now we have to prove that they bisect at right angles. Now for proving the bisection point, let me take triangle AOB and COD. AOB, COD. These two opposite angles we are taking. Now in this, how to prove that these two are congruent? Now see this. Since a square is a parallelogram, so opposite sides are equal and parallel. So this side CD and this side AB are parallel to each other. Now in this side you can see the formation of Z like this. You see this CD, AB. These two are parallel, and this BD will act as the transversal. So here you can see the formation of Z, that means the formation of alternate angles. So this angle CDO and angle ABO, this angle, these two will be equal by the reason alternate angles are equal. Then now we have shown this, that this angle in both the triangles are equal because they are alternate angles. Then we can see this angle AOB this one, and COD this one. These two angles are equal. Why? Because they are vertically opposite angles. The two angles we have shown equal. Third thing, in a square opposite sides are equal. So this side equal to this side. So you can see the criteria angle, angle, side. Angle, angle, side. So by AAS the two triangles are congruent. So we can say this side will be equal to this side and this side will be equal to this side. That means OA equal to OC, OB equal to OD. So the corresponding parts of the diagonal are equal. It means the diagonals bisect each other. So this we have to prove. First we have shown diagonals are equal. Now we have shown diagonals of a square bisect each other. Now we have to prove that they bisect each other at 90 degree. So for this we will take triangle AOB and AOD. See here in the figure, triangle AOB and AOD. AOB, this one, AOD, this one, means these two triangles. Now we are going to prove them congruent. Now see, this OA is common to both. Then this OD equals to OB. Why? Because right now we have shown that diagonals bisect each other. Third thing, this AD will be equal to AB because in a square all the four sides are equal. So we can see the rule side, 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 side. These two triangles are congruent. And if these two triangles are congruent, then by CP/CT this angle and this angle will be equal. This angle you can suppose 1, this angle you can suppose 2. So angle 1, angle 2 will be equal, which are named as AOB and AOD here. So they will be equal by CP/CT. Also we are watching that BD is a straight line. So this angle 1 and this angle 2 together forming a linear pair. So their sum will be 180 degree, which is shown here. Angle AOB means angle 2. Angle AOD means angle 1. So this is 2, this is 1. Their sum is 180 degree because they are making a linear pair. And as both are equal, so each should be of 90 degree. So what we have shown that this angle is of 90 degree. Similarly, we can show this angle and this angle is of 90 degree. So all the four angles are of 90 degree. So what we have shown, the diagonals are equal and diagonals bisect each other at 90